Hello.
Good evening, sir.
Yeah, good evening. Did you start the HCV kinematics?
Yes, sir. I read until projectile motion.
Okay. So basically, in kinematics, you have to learn about the basic terms that you need to be aware of. For example, some definitions like distance, displacement, then there will be speed and velocity, and finally, there will be acceleration. Do you understand the meaning of these terms?
Yes, sir.
So, what is distance?
That the distance is a way of measuring how much length has been covered by a body when time is passing in a frame.
So distance is simply the shortest distance between 2 points. If you take any 2 points, x1, y1, x2, y2,
No, sir. That is displacement. Distance can be anything, but it should just join the 2 points.
right now I'm talking about Cartesian distance.
Oh, okay.
What is the distance formula here?
X under root x2 minus x1 whole square plus y2 minus y1 whole square.
We are not talking about the physical meaning of how you reached. Right now we are defining what is the distance between 2 points.
Okay.
If you talk in a physics context and if you have taken a random path, then the length of that path is your distance covered, right?
Yes, sir.
Length of path. What is the displacement? If you have taken a path like this, what will be the displacement?
That answer which will come from applying the distance.
Displacement is the shortest distance between 2 points, right?
Yes, sir.
Also, there is a difference between the two quantities in the sense that this one is a scalar quantity, whereas displacement is a vector quantity. So if I have to write displacement, I have to specify which direction you have to go. So you will say that this vector is your displacement vector. It may have some x I cap plus some y j cap. The displacement vector will have an x component and a y component, right?
Yeah.
The resultant displacement, if you know the components of the vector, the resultant displacement is simply x square plus y square is the magnitude of the displacement, right?
Yes, sir.
The distance is the total length of this path, and obviously it depends on what kind of path you are going on.
Yeah.
Similarly, based on the distance and displacement, we can define our speed and velocity terms. Speed, average speed is defined as the total distance covered by total time, and average velocity would be the total displacement in whatever time it took. So average speed, you will say total distance by total time, and instantaneous speed. Instantaneous speed would be the rate of distance being covered per unit time. S here is distance. So we are taking the calculus derivative of the distance with respect to time. That will give us the rate at which we are covering distance at
Yes,
a
sir.
particular moment. On the other hand, if I talk about displacements and velocities, average velocity would be a vector because it is total displacement divided by total time, and total displacement is a vector. This is a vector. How do you calculate total displacement? You have to join the arrow from the initial to the final point and find that vector. That is the total displacement, right?
Yes, sir.
Similarly, you can also write it in terms of the position vector of the point. A position vector of any point is defined as the arrow from the origin to that point. So if P is this point, the position vector is the OP vector. And if you start from P and end up at Q, you can say that the position vector has changed from OP to OQ, right?
Sir, I have a doubt in this part, in the theory part of HCV on position vectors.
What is the doubt?
Sir, like for example, in this, the uh, the point changed from P to Q, right? So the displacement should be OP plus OQ,
No,
and
no. Displacement should not be OP plus OQ.
yes.
Point has changed from where to where?
uh, P to Q.
So displacement is PQ or is it OP plus OQ?
So that's the thing. In this, it is written that AB is AO plus OB.
What have you understood so far of what is displacement? If you go from P to Q, what is displacement?
PQ.
So why are you changing your meaning of displacement?
No, sir, I am not changing. It is written in the book.
Whatever is written in the book is correct. You are not understanding it properly. The displacement is PQ. We are not talking, OP is not a displacement. OP is the position vector of the initial position. And OQ is the position vector of the final position. If you start from a point P and you end up at a point Q, the displacement is this vector. But we are going to describe our initial position through an initial vector called position vector initial, which is OP. And we are going to describe our final position using this position vector, which is OQ. This is the final position.
So, sir, how will it be that OQ minus OP is the displacement vector?
Is this vector called your displacement?
Yeah,
You don't know how to add vectors.
sir, I do.
What is the vector sum of OP plus S?
OQ.
So OP plus
Oh,
S is
oh,
not coming as OQ.
I got it. I got it.
It is obvious that S is OQ minus OP.
Yes, sir.
By vector addition triangle law.
Yes,
And
sir, I got it.
therefore, displacement vector can be written as final position vector minus initial position vector.
Yes, sir.
You need to know what position vector is. A position vector is the vector joining the origin to your current position. If
Yeah,
P was at the point 2, 3, the position vector Ri, initial position vector is 2i plus 3j. If later Q was at the point 4, 1, your Rf is 4i plus 1j. And the displacement vector is the difference between final position and initial position vectors, which is basically 4 minus 2, 2i minus 2j. And you can see that this displacement vector has length of root 8, which is what you would get if you take this length.
yes, sir.
Do you understand what is happening?
Yes, sir.
Do you think there is something wrong written in Excel?
No.
There is nothing wrong in the text. This is the meaning that you have to understand.
Yeah.
You need to know what a position vector is and how the displacement is the difference of final and initial position vectors.
Yes, sir.
If you know your total displacement, if you divide the total displacement by total time, you'll get average velocity, which will be r final minus r initial by time. And if you want to do any instantaneous velocity, that would be the dr by dt. You have to differentiate the position of the point with respect to time. Basically, this means limit of delta t tends to 0, rt plus delta t minus rt divided by delta t, which basically means that this is the definition or meaning of a derivative. And we are saying that r is a function of time. So at time t plus delta t, r will be slightly different, right?
Yes, sir.
You are taking the new position vector at a slightly extra time minus the original position vector and dividing it by time and taking the limit of time becoming small. So that this tells us the instantaneous rate of change of the position.
Yeah.
So that is technically what is the meaning of this derivative. So that is derivative of the position vector with respect to time. Obviously, if the position vector is constant in time, if the position vector is not changing and is constant with respect to time, then dr by dt is equal to 0 or velocity is 0 because the position vector is not changing, right?
Yes, sir.
So that is your meaning of your velocity. Similarly, acceleration is simple. Acceleration is dv by dt, rate of change of velocity with respect to time. Velocity and acceleration and displacement are all vectors. Distance and speed are scalars. And now
Okay.
with these basic definitions, we can derive all our equations of motion. Equations of motion, there are three equations that you have seen before and you have used also in lower classes, right?
Yes, sir.
These three equation of motions can be derived from the basic definition of what these terms mean. For example, we know that the meaning of velocity is rate of change of displacement with respect to time, right?
Yeah.
So since it's a d by dt of displacement, we can say v dt is equal to ds and integrate both sides. And if you integrate this, I have started with the wrong thing here. We can start with a is equal to dv by dt, and that is the definition of acceleration. And if you start with this, you will say a dt is equal to dv and integrate both sides under appropriate limits. So the limits can be time 0 to time t. And at time 0, the velocity could be u. And finally, at time t, the velocity could be v. Right?
Yes, sir.
This is an integration of 1. So the integral here will come out as a v because the variable is dv. So it will come out as a v and you'll have to put u to v here. It will be v
Yeah.
minus u. On the right hand side, you'll get v minus u. On the left hand side, it depends on what this integral is. For now, we will be considering the special case that
E-
acceleration is constant,
Yeah.
constant in time. Constant in time means it is not changing with time, right?
Yes, sir.
Here the integral is over a time variable, but acceleration is constant in time we are assuming. So we can take a outside the integral because it's a constant. And
Yeah.
when we integrate this, it will be a integral of 1 will be t and you have to evaluate from 0 to t. So it will be a t minus 0. And from here we get the equation v minus u is equal to at.
Yes, sir.
or v is equal to u plus at. But you have to remember that this is only valid if acceleration was constant. If acceleration itself was changing, you cannot take the acceleration outside like we did here.
Yeah.
Suppose acceleration was itself increasing with time or changing with time, then you'll have to integrate whatever that acceleration is with respect to time. For example,
Yes.
acceleration could be t square plus 1. If that is the case, you will have to do this 0 to t, acceleration is t square plus 1, and we have to integrate this dt. So it will become t cube by 3 plus t. Evaluated from 0 to t. So the answer from here would be t cube by 3 plus t. And that would be your formula now. V is equal to u plus t cube by 3 plus t. Do you understand what I'm saying?
Yes, sir.
If the acceleration itself changes, these formulas are not valid. Only valid for constant acceleration, because we have taken acceleration out of the integral, assuming that it will be fixed. And from there we got v is equal to u plus at.
Yeah.
Once we have v is equal to u plus at, the first equation we have derived, we can write velocity as the rate of change of displacement with respect to time is u plus at, right?
Yes, sir.
Take the at on the other side and do the integral again. The integration of displacement means from starting from initial position, which is initial displacement vector, to the final position. That is going to be your total integral here, right?
Yeah.
Then this is also starting from 0 to time t. You will get on this side Rf minus Ri, which is basically your total displacement vector, is equal to, on the right hand side, you get ut plus half a t square, evaluated from 0 to t. So ultimately you end up with S is equal to ut plus half a t square, right?
Yes, sir.
This S stands for the total displacement that has happened. Is it clear?
Yes, sir.
So that is the derivation of your second equation. Again, it is coming from the first equation and a simple integration after realizing the definition of velocity.
Yeah.
The third equation of motion is v square is equal to u square plus 2as. We can derive this also. We can say that acceleration was equal to dv by dt. But instead of dv by dt, we can write it as dv by ds times ds by dt also, right?
Yes, sir.
Here dv by ds is basically the derivative of velocity as displacement changes.
Yeah.
As the displacement changes, how fast is the velocity changing? So also ds by dt is just a velocity, right?
Yeah.
So you're getting v dv by ds is equal to a. You can do a ds is equal to v dv and integrate this from initial to final displacement and initial u to final v, right?
Yes, sir.
So on the left hand side, you're getting a times rf minus ri, which is total displacement vector, right?
Yes, sir.
On the right hand side, you have v dv integrals, that is v square by 2. So you get v square minus u square by 2. And now you can write v square minus v square is equal to u square plus 2as.
Yeah.
Do you understand how all of it has been derived?
Yes, sir.
The important thing to realize here is that all of these three formulas are assuming that, for example, here if you see a is a constant, that's why I was able to take it outside and integrate the inside one.
Yeah.
So this particular definition, these particular definitions you need to be clear on. And we have derived all the three equations that you will be using. So that is good. Now, what you need to learn here is applying all of these equations in different situations. The only thing that you need to remember is that uh, these equations are not always valid. They are only valid when acceleration is constant, right?
Yes, sir.
If acceleration was not constant, we cannot take the A outside here.
Yeah.
So the derivations of these three equations are done. Then the main idea here is projectile motion is the main topic here in this section. But before we do that, you have to understand that a particle can move in 3D space any way it likes, right?
Yes, sir.
And you have R, the position of that particle can be represented with using three variables, I, J, and K. These three variables are basically unit vectors in the X, Y, and Z directions, right?
Yeah.
Anytime a particle is somewhere, you can draw a position vector to its point, Ri, right?
Yes, sir.
So this position vector helps us understand what kind of a motion will happen. You should notice that when you do projectile motion, both the X and the Y values keep changing.
Yes, sir.
The motion is basically in two dimensions. There is a Y axis, there is an X axis, and the projectile is thrown at an angle theta speed u. Now, this velocity has two components, one vertical component uy and one horizontal component ux, right?
Yeah.
So if you have these two components, then what we know about projectile motion is that once the ball is flying in the air, the only force acting on it everywhere is the gravity force, right?
Yes, sir.
If gravity is the only force acting, then which uh which basically you have to say which direction does gravity influence the body? Which direction? X-axis, Y-axis, and so on.
Okay.
Gravity is trying to bring the particle down, right?
Yeah.
It is acting completely in the X-axis direction, in the Y-axis direction. And the force
Yeah.
of gravity is mg and mg, right?
Yes, sir.
There is no horizontal force, on the particle. When it is in air, there is nothing on the particle except gravity, right?
Yeah.
So one important discovery was made that whenever we think about bodies that are moving in more than one dimension, it is convenient and it is correct that you can do the x-axis and the y-axis independently. By that, I mean, if you're trying to find something about x-axis, then you don't need to find anything about the y-axis to be able to predict that. Like the motion in x-axis and y-axis are completely independent of each other. Do you understand what I mean?
Yes, sir.
You don't have to worry about x-axis stuff when you're trying to do y-axis calculations.
Yeah.
So similarly, vice versa. So now here, what we will see is that if a projectile was thrown with an angle theta and a speed u, then I will label my x and y axis. This is my y axis and this is my x axis. Now your u velocity has two components, ux and uy. And ux is basically, if you see this situation, there is a triangle like this, u is like this, theta is like this. So we have to find out u of x. correct?
Yes, sir. U cos theta.
Hmm. And similarly, u of y would be u sine theta, right?
Yeah.
The reason we are writing them separately as u of x and u of y is because we will solve them also separately. The motion in x will be solved separately and motion with y will be solved separately.
Yes, sir.
Now, if you think about it, there was no horizontal force on the particle, on the ball. No horizontal force was there, right?
Yeah.
So if there is no horizontal force, then there cannot be ax, right? Ax must be zero, right?
Yes, sir.
Ay would be basically
G.
minus g because it is downward direction.
Yeah.
Other velocities are upward and all, gravity is downward, so we'll put a minus g there, right?
Yeah.
Now, the first thing that you need to derive here is how much time it takes for the particle to fall back on the ground. So that is known as time of flight. So if you start like this and come down here, you should realize that the difference between P and Q point, the only thing is that that is the total range that is called. And if you go from P to Q, the displacement has only X component, right?
Yes, sir.
It is zero in J, right?
Yeah.
So you can say that the displacement in Y is zero, correct?
Yes, sir.
If displacement in Y is zero, we can say final displacement y is 0. So 0 is equal to ut. We are doing the y direction, so it will be u sine theta t minus half gt square, right?
Yes, sir.
Do you understand how I'm getting this? U sine theta t ut minus half gt square, that is 0,
Yeah.
right? Now you can cancel one t here and you'll get gt is equal to 2v sine theta. So time taken is 2v by g sine theta, correct?
Yeah.
This expression becomes your time of flight. You can also write it as 2 times uy by g
Yeah.
because uy was hurt. Uy was
U.
basically u sine theta, right?
Yeah.
I hope you are understanding what I'm saying.
Yes, sir.
Time of flight we have calculated. Another thing we can calculate is the maximum height in the y direction, right?
Yeah.
So in order to do that, you can again say that maximum height. So we can say that the vertical velocity Vy at this moment must become zero, right?
Yeah.
Initially, vertical velocity was u sine theta, but now it must become zero because if it is not zero, the ball will keep going up, right? Then
Yes, sir.
the u sine theta is decreasing as the ball goes up. It becomes zero for a moment and then it starts increasing again.
Yeah.
Correct? Okay. So if the vertical velocity is zero from the first equation, 0 is equal to u sine theta minus gt, right?
Yeah.
So the time at which this happens is u sine theta over g, right?
Yeah.
Notice that this is half of the 2u sine theta over g, which was the time of flight.
Yes, sir.
So basically what we are getting is that if it is a normal level field and you have launched a projectile, exactly half the time it is going up and half the time it is coming down. So the time of flight is 2u sine theta by g, whereas time for maximum height is 10u sine theta by g.
Yes, sir.
And if we know the time at which maximum height happens, now we can derive the maximum height by using the second equation. So say S is equal to ut. So u sine theta into t is u sine theta by g. Minus half into g into u square sine square theta by g square. Right?
Yeah.
So you get u square sine square theta by g minus u square sine square theta by 2g. So the height maximum is u square sine square theta by 2g.
Okay.
So it is again coming by applying the first and second equation from this initial point to the point at which it reaches highest point. And at highest point, the vertical velocity is 0, right?
Yes, sir.
Similarly, the final equation, which is range of the projectile, that will come by seeing that the horizontal speed of the particle is always fixed
Yes, sir.
because there is no force in the x direction. So there is no acceleration in the x direction, which means its x direction velocity cannot change.
Yeah.
And if x direction velocity is not changing, the distance it will cover will be that velocity times the total time of flight, right?
Yeah.
So the total range is basically u square into 2 sine theta cos theta by not u.
U square sine 2 theta by g.
Okay, something weird has happened. My stuff is getting erased. Okay, 1 second. U square sine theta cos theta times 2 by g. And this 2 sine theta cos theta becomes sine 2 theta by g.
Yes, sir.
So it's not important to just memorize the formulas. You need to know how each result is coming.
Yeah.
So the point is, every time we are deriving the result on the basis of splitting the motion into y and x direction motion. Your initial u was u cos theta in x, u sin theta in y, and angle was theta. And we can find everything if you just focus on, okay, if I want to find time of flight, I need to make sure that the displacement in y becomes 0, right?
Yeah.
That's how we found time of flight. It came out to be 2u sine theta by g. And if I want to find point at which maximum height happens, I need to focus on Vy should become 0 here. And we got time at which it happens is u sine theta by g. And if you calculate the maximum height, it will come as u square sine square theta by 2g applying the second formula.
Yeah.
And similarly, the total range r is equal to u cos theta times the time of flight 2u sine theta by g, which can be written as sine 2 theta into u square by g.
Yes,
Is
sir.
it clear?
Yes, sir.
These equations are not valid if the acceleration itself is changing.
Yeah.
So now what you have to do is practice some problems. Projectile, there will be several problems in the examples and exercise. You need to learn how to solve your projectile motion questions and your basic mechanics, kinematics questions where particles are moving around.
Yes, sir.
You have to try examples, exercise. There is one thing that is left in the chapter, which is relativity. You have to read that theory in the chapter and see if you're not understanding anything, we'll discuss it.
Okay, sir.
Just focus on chapter 3 as much work as possible in HCV. That's your work for Wednesday.
Okay,
Okay,
sir.
fine. That's all for now. Try the questions, see what is coming, what is not coming for you. We'll discuss on Wednesday then.
Okay, sir. Thank you, sir.
Hmm.